we are working on. So we are developing an algorithm designed to and efficiently pack 2D polygon as closely as together as possible. So this is our test case basically, and let's move to our main ERP screen. And this is our ERP screen. So this is houses and plans that we are working on. And let's see a map. Okay, so this is our map and wait. Okay, so now if we like click this and this will pack all the polygons. Basically, this is not a polygon. This is a bedroom, kitchen, drawing room, and all of the thing door. Basically, ultimate goal is to minimize the space between these polygons during the packing. Like we click button and this is see this is our packing. So the unused space is minimized. Means if we are completely laying down the carpet, so the wastage is minimum. This is our primary goal to minimize the wastage, and if we minimize the wastage, the cost is also reduced. So if we pack this like that, so it will increase the unused space area. If we increase the unused space area, the cost is also increased. So this is not our aim. So our aim is to reduce the unused areas as much as possible and pack the polygons as much as closer. So the cost is also reduced. So basically, let's move to our algorithm. Like we are right, this is our test cases, and this is our algorithm. Let's see one case. Okay, this is our first case. Like we are working approximately 20 to 20 to 25 cases, like right, and we got them and check. Okay, so see, this is there is the polygons like one, two, three, four polygons, and my algorithm pack all the polygons successfully. And if we see that there is a minimum unused space area, so if we use a minimum unused space area, so the cost is also minimum. So basically we achieve our task to minimize the unused space area, and this if we move polygon like this is not efficient way. Okay, so if that polygon pack here or if that polygon pack to upper side, so this is only a one thing because we achieve our goal to that our goal is to minimize the user space area. Okay, so let's see one more case. Basically this case this is a case that okay, let's see paste to run. Okay, so let's see. This is not a best packing. So that we are talking about if that polygon, like the polygon number one, two, three, four, the fourth number of polygon moved upper side like this. If that polygon move upper side and this polygon, null polygon, which will at the last, this polygon right here. So this is our best case because the unused space area is less, and if we pack that polygons and the cost is also reduced. So we write that another algorithm to pack this particular case. Like we are already packed all the cases, and for this case we have to some change do so some changes in our algorithm. Okay, see that we are talking about. So the polygon number, the fourth number of polygon packed upper side, and after that this last polygon can be shifted to upper side. So this is our best case, and we are work to perform these cases, and this is our basically task. Okay, thank you everyone.